So discriminants, right? In A-level quadratics, what you should have been reading about. Given any quadratic with ax squared plus bx plus c that you recognize from GCSE, right, equals 0, we can use the quadratic formula to jump straight to a solution, okay? X equals, as you can see, minus b plus minus square root of b squared minus 4ac, all divided by 2a. All right, so that's again something you recognize from GCSE. All right. The special part of this that they focus on in the A-level spec is this bit here. Let me highlight that bit there. All right. Yeah. So effectively, b squared minus 4ac, that is called the discriminant.
Okay.
Discriminant. Here we go. All right. Now, before jumping into that, no, I will jump into it. Actually, change my mind. So what happens is you can see that you have to square root this thing.
Yeah.
All right.
Yeah.
And the first thing that you would recognize is that there were some rules about this. If b squared minus 4ac is, I'm going to do that, is less than 0, right? It's negative, okay?
Yeah.
Therefore, you can't square root it.
Yeah, because negative, yeah.
Okay. So therefore, the whole solution stack, right, that formula is not valid. And consequently, right, that means there are no solutions.
Okay.
Right. If, on the other hand, b squared minus 4ac equals 0,
Yeah.
right, then all you have, the result, becomes minus b over 2a. Right? Go back to this. Do you see you cancelling out?
Yeah, because all that is 0.
Yeah, all you've got is the minus b over 2a.
Yeah.
So that gives you one solution only.
Mm-hmm.
All right? And I'll illustrate these things in a moment. The other option, b squared minus 4ac, is greater than 0. Okay? Then you actually have two solutions. Okay? Mm-hmm. So that'll be two distinct solutions. All right?
Yeah, I get that, yeah.
Right. So overall, the rule that you're looking at, for there to be solutions, the condition is this: must be greater than or equal to 0.
Equal to 0, yeah.
All right? That's the rule. Okay. Now, what does a discriminant actually mean? All right, just a little bit of extra discussion on it. If you have a standard quadratic, all right, so just so I can draw one. Here's the difficult bit. Hang on. Not bad. That'll do. Okay.
Mm-hmm.
Imagine this one has two solutions. All right.
Yeah.
So I don't know, Q, for example. All right.
Mm-hmm.
If those solutions are represented by, for example, if I write it like this, minus b minus b squared minus 4ac over 2a, all right? So that's the first one on the left, the lower value.
Yeah.
And q equals minus b plus the discriminant square rooted. Okay, that's that one there. Notice, right, and this is a bit that often is overlooked and not even discussed in the textbook sometimes, but it really helps at the higher levels in A-level questions and things. Look at what we have in each case. We've got minus b over 2a, and then plus or minus a particular value, right? Whatever that is, the b squared minus 4ac. So effectively, right, think about it. My graph is not quite symmetrical, but I think about there, right?
All right, yeah.
The dead center of the quadratic graph, that must be the minus b over 2a.
Oh, I get it, because you're just plus
Right?
and minus.
Yeah. And then the bit on the right-hand side to the positive direction must be plus a value. So that's your discriminant, isn't it?
Yeah.
You see? So whatever the value is. And on this side is the minus the same value. So do you see how the two solutions are symmetrically, right, positioned about that center point, and the center point is the minus b over 2a.
Yeah.
Okay? So every quadratic will have a line of symmetry, and that will always be minus b over 2a. Okay? Regardless of whether it actually has solutions or not. All right. Fine. Next thing, I'll show you what's going on here. Same sort of graph. And yeah, okay, I'll do it here. Okay. So if you have one that does that, all right, and another one does that, and let's put this one here, I suppose. Those are the three conditions for the discriminant.
I see what you mean. No
Right.
points, 1 point, 2 point.
Yeah, all right. So this one, the first one here, it never crosses the x-axis, all right? So therefore, your b squared minus 4ac is less than 0, negative. It doesn't have a square root, okay?
Yeah.
This is the one I was saying where b squared minus 4ac equals 0, okay? Now that is known as a repeated root. So in other words, if I had, for example, in this particular graph, imagine that that number was 3,
Yeah.
all right? So this one would be a straightforward x minus 3 squared quadratic. So that could be, for example, x squared minus 6x plus 9, all right? And so in other words, that is a perfect square. It has no other bits and bobs and whatever. Okay? And the final one, that one. And that one is where b squared minus 4ac is greater than 0. Right? And as you can see, it has two solutions. Okay? Does that make sense so far with all the discriminant stuff?
That does,
Right?
yes.
That literally is the fundamental principle of the discriminant, as you can see there. All right.
Yeah.
The uses for it, okay, is sometimes, examples of why they want you to know this. They say, a tangent to a circle, for example. All right. In other words, they give you a line and a circle, and they say, is it a tangent? All right. So if you then try and equate the two, why? So for example, I'm going to make this up randomly, so it may or may not work. I'm not interested in the actual numbers. So you've got y equals mx plus c, right? And you've got a circle which is x squared plus y squared equals r squared. That's a standard equation for a basic circle on the origin, all right?
Yeah.
Fine. So what you would do is try and equate the y's, eliminate the y's, all right? So you get x squared plus, substitute for the y, okay? Assuming you know the m, you know the c, and you know the r, all right? You expand all that out and you get a quadratic in x. Right?
Yeah.
And to prove whether the lines and the line in the circle actually intersect or not, you don't necessarily have to solve the quadratic. You check the discriminant. Okay?
Yeah.
Meaning, when you expand this whole thing out, whatever the coefficients are of the x squared, the x, and whatever, and r squared is just a constant,
Yeah.
you apply the rule. You check b squared minus 4ac for the final quadratic, and is that negative or more or equal to 0, more than or equal to 0, right?
Yeah.
So if the discriminant of that equation is negative, then the two lines, or the circle and the line, never intersect.
Yeah.
Okay? In other words, there's no solution, so they don't touch. On the other hand, if it's either 0 or greater than 0, they intersect. Now, special condition. If it's 0, okay, if exactly 0, the discriminant, then it's a tangent. Why? Because look, you'd have
Only 1 point up.
only one, yeah? And if it's greater than 0, then you'd have like that,
Yeah. Yeah.
okay? And of course, if it's less than 0, the line doesn't actually touch or cross the circle, okay? So that's just an example. This often comes up in geometry, okay, to prove some sort of a geometric relationship. And you get it in many other places where you're trying to solve something and see whether there is a solution or not. That is the main purpose of the discriminant. Okay? Any questions?
No, I'm good.
No? All right then, let's pause there.